Hey guys, welcome to another episode of Learn with Sir Glenn. So, for this video, we're going to discuss infinite geometric series. Let's go! The infinite geometric series is actually the sum of all terms of infinite geometric sequence. So this is different from the finite geometric series. In the finite geometric series, we just simply add a specific number of terms on your geometric sequence. While in the infinite geometric series, we're going to add all the terms of an infinite geometric sequence. The infinite geometric series is denoted by S sub infinity. So, how to solve an infinite geometric series? So we can use the formula for the infinite geometric series, which is S sub infinity is equal to A sub 1 over 1 minus R, where S sub infinity is the infinite geometric series, A sub 1 is the first term, and R is the common ratio. But if we're going to think of it, how are we going to find the sum if there are infinite number of terms? So in infinite geometric series, there will be a restriction. It is only applicable if the R is between -1 and 1. So examples of these are 1 half, 1/3, 2/3, -1 half, and etc. So you can only find the sum of infinite geometric series if your common ratio is between -1 and +1. So what will happen if your common ratio does not belong to this interval? So if the common ratio is less than or equal to -1, or the common ratio is greater than or equal to 1, the value of the sum does not exist. So you can only find the sum of infinite geometric series if your common ratio is between -1 and 1. How to use the formula for infinite geometric series? Suppose you want to find the sum of 81 plus 54 plus 36 plus 24 and so on. So before you proceed with the formula, you have to identify first if this infinite geometric series has a sum or if the sum does not exist. And to do that, we're going to identify if the common ratio is between -1 and +1. So therefore, let's solve for the common ratio first. And for this one, our common ratio is equal to 54 over 81 by dividing any consecutive term divided by previous term. So since 54 and 81 are both divisible by 27, which is the GCF, you divide both by 27. By doing that, we will have the common ratio is equal to 2/3. So since 2/3 is between -1 and +1, therefore, the sum exists. So since the sum exists, we can now use the formula to find the sum of this infinite geometric series, and which is S sub infinity is equal to A sub 1 over 1 minus R. So before we can use the formula, we have to identify first the values of our variables. So we will have S sub infinity is unknown because that's what we're looking for. A sub 1 is 81 because that is the first term of your geometric sequence. And R is equal to 2/3. After this, we're going to replace the variables on our formula with the values that we obtained. So therefore, we will have S sub infinity is equal to 81 replacing A sub 1 all over 1 minus 2/3 replacing R. So working on this, we will have S sub infinity is equal to 81 over 3 over 3 minus 2/3. So what we did here is we rename 1 as 3 over 3 so that it will become a fraction. At the same time, it has the same denominator as 2/3. So now we can now subtract 3 over 3 minus 2/3. So that will give us S sub infinity is equal to 81 all over 1/3. Then, we have to divide this. So, we will have S sub infinity is equal to 81 divided by 1/3. So, to divide this, we get the reciprocal of the divisor, then proceed to multiplication. That's why our equation now will become S sub infinity is equal to 81 over 1 times 3 over 1. So, what we did here is we take the reciprocal of 1/3. That's why we have now here 3 over 1. Then, replacing the operation from division to multiplication. So all we have to do now is to multiply these fractions, numerator to numerator, denominator to denominator, and that will give us s sub infinity is equal to 243. So if we're going to add 81 plus 54 plus 36 plus 24 and so on, the sum is 243.
Wow!
Okay, so let's have another example. Let's say you want to find the sum of 12 plus 24 plus 48 plus 96 plus and so on. If you want to solve for the infinite geometric series, the first thing that you're going to do is to identify if the sum of this infinite geometric series exists or not. To do that, we're going to check if r is between -1 and 1. To do that, we just simply get the common ratio, and for this one, we will have 24 divided by 12, dividing any consecutive term divided by the previous term. So simplifying 24 over 12, you will have r is equal to 2. Since 2 is not between -1 and +1, then the sum of this does not exist. So you don't have to solve for this one because the sum has no limit.
Nice.
Okay, so let's proceed. So, suppose you want to find the sum of 128 plus -64 plus 32 plus -16 plus and so on. So again, the same with the previous examples, first what we're going to do is to identify if the sum exists or not. So to do that, we're going to identify if r is between -1 and +1. So let's get the r. So the r is equal to -64 over 128 by dividing any consecutive terms. So since we can simplify this by dividing both by the GCF, which is 64, we will have r is equal to -1/2. So the -1/2 is between -1 and 1, so therefore, the sum of this infinite geometric series exists. Since the sum exists, we can now use our formula s sub infinity is equal to a sub 1 over 1 minus r. So, but before that, we have to identify first the variables in our formula. So, we have the s sub infinity is unknown since we are looking for the infinite geometric series. The a sub 1 is 128, which is the first term, and the r is -1/2, which is the common ratio. After this, we replace the variables on our formula with the values that we obtained. So therefore, we will have s sub infinity is equal to 128 all over 1 minus -1/2. So solving for this, we will have s sub infinity is equal to 128 all over 2 over 2 plus 1/2. So what happened here is that we rename 1 as 2 over 2 so that it will become fraction. At the same time, it has the same denominator with 1/2. Then you change the sign of the subtrahend, proceed to addition. That's why instead of subtraction, you now have 2 over 2 plus 1/2. So working on this, we will have s sub infinity is equal to 128 over 3 over 2. Adding the numerators of 2 over 2 plus 1/2, then copy the common denominator. So continue it here, you will have s sub infinity is equal to 128 over 3 over 2. S sub infinity is equal to 128 divided by 3 over 2. Then to divide this, all you have to do is to get the reciprocal of the divisor, then proceed to multiplication. So that's why you will have here s sub infinity is equal to 128 over 1 times 2 over 3. From 3 over 2, we now have 2 over 3 because that is the reciprocal of 3 over 2. Then instead of dividing the numbers, we're actually multiplying it now. So that's the process in dividing fractions. So get the reciprocal of the divisor, then proceed to multiplication. So all we have to do now is to multiply numerator to numerator, denominator to denominator. So that's why we will have s sub infinity is equal to 256 over 3. So if you add 128 plus -64 plus 32 plus -16 and so on, the sum is 256 over 3. Okay, so let's have our last example. So find the sum of 64 plus 16 plus 4 plus 1 and so on. So again, we have to identify first if the sum exists. So to do that, we have to identify if the common ratio is between -1 and +1. Just simply get the common ratio. So we will have common ratio is equal to 16 over 64 by dividing any consecutive terms. Then we simplify it by dividing the numerator and denominator to your GCF, which is 16. So by doing that, you will have common ratio is equal to 1/4. So since 1/4 is between -1 and 1, the sum of this infinite geometric series exists. So therefore, we can now solve it using our formula, which is S sub infinity is equal to A sub 1 over 1 minus R, where S sub infinity is unknown. A sub 1 is 64 because that is the first term of our geometric sequence. Then R is equal to 1/4, which is our common ratio. We can now replace the variables in our formula with these values that we obtained. So therefore, we're going to have S sub infinity is equal to 64 over 1 minus 1/4. So A sub 1 is replaced by 64, R is replaced by 1/4. So solving for this, you will have S sub infinity is equal to 64 all over 4 over 4 minus 1/4. So we rename 1 as 4 over 4 so that it will become a fraction with the same denominator as 1/4. So subtract 4 over 4 minus 1/4, you will have 3 over 4. So dividing this, we will have S sub infinity is equal to 64 divided by 3 over 4. And to divide this, we get the reciprocal of the divisor, then proceed to multiplication. That's why we will now have S sub infinity is equal to 64 over 1 times 4 over 3. So from 3 over 4, you get the reciprocal. That's why you have 4 over 3. From division, you will now have multiplication. Then all you have to do is to multiply numerator to numerator, denominator to denominator. And that will give us S sub infinity is equal to 256 over 3. So if you add 64 plus 16 plus 4 plus 1 and so on, the sum is 256 over 3. So that's it. We're done. Thank you for watching and hope you have learned something from this video.